Okay, in chapter section 5.3 and 5.4, we're going to talk a little bit about triangles. So triangles, of course, is a three-sided shape, as we discussed before. So there's one side. I'll make these vertexes, little dots. Two sides and three sides. So often we label the vertexes, and I'm going to label them with letters. Capital letters is a good way to do it. And we can then label the angles. For example, this angle we could call again angle BCA. But more simply, we could just call it angle and use a lowercase c. Angle C. Or no, wait, let's stick with the uppercase C. The reason is because, so I'll make this a capital C. Often the opposite side in a triangle we will label as the lowercase letter. So this is side C, side B, and side A, because there sometimes are equations where we need to use those. Okay. We have different types of triangles. Use this triangle tool here. Want to kind of make the angles a little different. So, whoops, too much of an erase. Wow, really went back there. Okay, so I've drawn this triangle again. And so in this case, whenever you have a triangle where the angle A, the angle B, and the angle C are all less than 90 degrees, when that's the case, we call that an acute triangle. So the length of the sides can be any length, and these angles can be any angle so long as they're less than 90 degrees. Okay, when we have a triangle where one of the sides is 90 degrees, we'll call this a right triangle. One of the angles, I think I said side, one of the angles is 90 degrees. The sides can be any length at all. Right triangle. Let's write one angle less than 90 degrees. Okay, if you draw a triangle where one of the sides, in this case, would be this side. Note angle A is greater than 90 degrees. So we call this an obtuse triangle. So one angle greater than 90 degrees. The sides again can be any size. Here are two more triangles. Call this one an isosceles triangle. here, two sides and two angles are the same. If all the sides and all the angles are the same, call this equilateral. And I already broke my rule. Let me go fix that. Okay, so an equilateral triangle, angle A equals angle B equals angle C, and side A equals B equals C. They're all the same length. Okay, the sum of all angles in a triangle always equals 180 degrees. For example, we could have this angle here that say is maybe 82 degrees. This angle is 65 degrees. Then this angle has to be 33 degrees, because 33 plus 82 plus 65 equals 180. So we can use this idea and some of the other ideas that we've learned to solve problems. For example, so I have this problem. There's a straight line here with a triangle sitting on top of it. We know that the angle over here on the left is 63 degrees, but we don't know what the two other angles in this triangle are. But we do know that this angle between the surface here and this outside edge of the triangle is 105 degrees. So how do we find angle A and angle B? Well, from the previous chapter, we know that in a straight line, if we go, it's like halfway around a circle, or 180 degrees. So in order to find angle A, we know that angle A plus 105 degrees equals 180 degrees. So we can do algebra here to find these angles. So angle A then equals, so essentially what I'm going to do here is I'm going to subtract 105 off of each side. That will eliminate this, isolate angle A. So 180 minus 105, that equals, well, 180 minus 105 equals 75. Okay, so if angle A equals 75 degrees, we just learned above that all the angles in a triangle have to equal 180 degrees also. So 180 degrees, so let's say here for triangle. (180 degrees) now equals angle A plus angle B plus 63 degrees. So that means angle A is 75 degrees plus angle B plus 63 degrees equals 180 degrees. So I isolate angle B. We need to bring these over to the other side, so I subtract off essentially minus 63 and minus 75. So I got minus 75, minus 63 over here. These will cancel out. I'm going to be left over here with just angle B, and angle B equals, here I plugged it into the calculator, and it equals 42 degrees.